Okay, I'm going to do a couple of examples today that will help you with tonight's homework. The first one is solving for x in this exponential equation. And it looks a little strange, but I have to isolate the x, the power, which is 4 to the x. So I'm going to start by dividing both sides by 3. So I'm going to have 210 divided by 3, which is 70. And then I have plus 1/3 times 4 to the x. So I've got 70 plus 1/3 times 4 to the x is equal to 4 to the x power. And then what I have to recognize is I have 1/3 times 4 to the x on the left side, and I have 1 times 4 to the x on the right side. So I'm going to actually subtract 1/3 times 4 to the x on both sides. It's helpful if you think of it as if you're doing 3x squared minus, let's just say, 1/3 x squared. And that would leave you with 2 2/3 x squared. So it's the same concept because 1/3 is a coefficient of the power, and on the right side 1 is a coefficient. So I end up with 70 is equal to 1 minus 1/3 is 2/3 4 to the x. And then I have to basically multiply both sides by 3/2. So 3/2 here. And of course they will cancel on the right side down to a 1. And then 3 times 70 is 210 divided by 2 is 105 is equal to 4 to the x. And now I'm going to take the log of both sides. So this is sort of the new material. And then that allows me to bring the power x out front, turning it into a division problem, which I can easily solve using my calculator. So I'm going to divide both sides by 4, divide both sides by, I should say log of 4, that's really important. So x is going to equal in exact form log of 105 divided by log of 4. And you make sure to close your parentheses when you're doing it in your calculator. But this is exact, and we could use a calculator if we have it to get an approximate answer. Number 2, so we're investing $500, and we're going to invest it for 4 years. It's going to be compounded continuously. When I read that, I know I need to use my PERT formula, which means the amount of money I have after a certain period of time is the initial investment or principal times e to the RT. So I'm going to have 500 doubling, turning into 1,000, e, and then I don't know my rate, but I do know the time is 4, so I'm going to write 4r. So I'm going to solve for this r by using logs, or taking the log of both sides. But first I must isolate the power, which is e to the 4r. So divide both sides by 500. Of course I get 2 on the left side. And then I would take the log of both sides at this point. But I don't want to use logs. I want to use, not common log, I want to use natural log because my base is an e. So taking this up here, I have natural log of 2 is equal to 4r times log of e, natural log of e, which ln of e is just 1. So r will be natural log of 2 divided by 4. And this is the exact answer. Be sure to close the parentheses if you're using a calculator. Now the next problem is probably the most challenging one. And I'm going to start by just sort of determining what information I have. I know that the half-life is 5,730, and that's for carbon-14. And they're measuring the amount of carbon-14 to determine the age of the fossil. And we want to know the age of the fossil if 15% of the original carbon-14 is remaining. So this is kind of an interesting problem where I'm going to use, sometimes I've kind of referred to it as the NERT formula, but the amount of substance after a certain period of time will be equal to the starting amount, e to the negative kt, and this is a decay constant. Okay, so what I need to do first is find k, and then I can find time for the amount of the substance to decrease to 15% from 100%. So the first thing I'm going to do is recognize that if I have a half-life, I may start with 1 unit of the substance and I would end with 1/2. They don't tell us exactly what the units are. So I have e to the negative k, and I know how long it takes for half of the substance to decay. It's 5,730. So I'm just going to use the natural log on both sides. So ln of 1/2 is equal to, and remember that I'll be able to pull the exponent down front using the power property once I take the ln on the right side. So I'm going to have a negative 5730 k times ln of e, which ln of e is just 1. So to find k, I'm going to divide both sides by negative 5,730, negative 5,730. And this is exactly k. This is an exact form. Now, I'll probably do that in the calculator and even maybe store it or use it immediately in the next part. So before I actually find this in the calculator, I want to set up the next part of the equation. And remember that this is k right here. So the next part of the equation, I will have 100% of the carbon-14 when the, whatever, it was a saber-toothed cat, passed away. Now I've got 15% or 0.15 remaining. And I want to know how long that took if I know k is whatever this value is. So set up your equation just like that and go ahead and we're going to solve for time. I'm going to do that by taking the natural log of both sides. And then the negative kt will be basically brought down front using our power property. ln of e is just 1. So I'm going to divide by negative k to solve for t. So t time is going to be natural log of 0.15 divided by a negative k. And remember, k is going to come from this value there. Now, the negative is really in the equation, so the k part is just going to be substituted from what we found earlier. So let me show you how to do this in your calculator real quickly. And I'm going to take, first of all, the natural log of 1/2. And let me clear this out before I get started. So the natural log of 1/2, and then that will be divided by negative 5,730. And I do want to make sure that's exactly right. Sorry. So, yes, negative 5,730. So going back to the calculator, I have, this is correct. So I will press enter. Now that is exactly k. So I'm going to store that, and I'm literally going to store it as k. So I'm going to turn on my alpha feature. My alpha basically it turns on all the green options here. So store it as k, press enter. And then when I do the next part of the equation, which is just going to be ln of 0.15 divided by negative k. So then I do ln of 0.15, and that value gets divided by a negative, and then I just recall k, which is alpha, and then press the k button. So ln of 0.15 divided by negative k, and the fossil is 15,682, almost 83 years old. So that is how you would solve one of those problems. Okay, I'm going to do just a couple more examples and want to remind you of a couple of properties, sort of properties that we've talked about before, but just kind of reminding you. The natural log of e is 1, and that's because log base e really is ln. So ln of e obviously be 1 because e to the first is e. So that's the first one. The next one, if I have ln of e to some value such as x, it will simplify down to x. And this is the property we learned earlier this week, which is log of a base, and then I have that same base to some value x will simplify down to x. So this is ln of e to the x will be x. Now the next one is e to the ln x is equal to x as well. And this is the one where you have an exponential, where you have a base, And then you have a log with that same base of x will simplify down to x. So e is raised to the log with the base of e. Obviously, that's really just your ln. So those are three properties. So if I see something like this, so this is just an example. If I see something like e ln of x to the fourth, this whole thing just simplifies down to x to the fourth. Now, if this were set equal to 16, for example, then what I would do is I'd say x to the fourth is equal to 16, and then I would take the fourth root, meaning x would be plus or minus 2. So because I'm raising it to the fourth power here, it's okay to have a negative in the original equation. So that's one example. The next one is, what if I have something like this? 3 times ln of x minus 4 equals 4. Now this is one where I have logs on the left, but I don't have logs on the right, so I'm going to eventually want to rewrite this. But I have to isolate this ln of x before I can do that. So the first thing I want to do is add 4 to the other side. So I get 3 ln of x is equal to 8, and I'm going to I have two choices here. I can divide both sides by 3, or I can use the 3 as a power. I think I'd rather do that. So ln of x cubed is equal to 8. And then I can rewrite it e to the 8th power, because this is an understood e, is equal to x cubed. Now, I have to take the cube root of both sides, which would be raising to the 1/3 power. 1/3 power. So then I would get x is equal to e to the 8/3 power. And that would be your answer. And if you didn't have the calculator, you could leave it just like that in exact form. Now, if I had decided, let me do it the other way I mentioned, to divide both sides by 3. So this is where I am in the problem. Divide both sides by 3. These will cancel, of course. I have ln of x is equal to 8/3. And then I have e to the 8/3 is equal to x when I rewrite it. So do you see I'm getting the exact same answer either way I do it. And that is sort of the tricky thing about logs, is there are different ways to approach the problem. So you just have to practice a lot and get comfortable with the way you want to approach it. And you have to know at least one way to do it. So that's pretty much where logs are. All right, that recaps what we did today in class and should give you enough so that you can do tonight's homework. Thank you.